Let's find out what's new in Windows Server 2016 with software-defined networking. Before we get started, let's first understand the problem software-defined networking, or SDN, is solving. Applications are innovating at a rapid pace, and network infrastructure, with its complex set of connections and devices, can't keep up to meet the needs of those applications, all while ensuring constant uptime. Server virtualization solves this problem for servers by placing the application into a virtual machine that is separate from the hardware on which it's running. With SDN, we create a network virtualization layer on top of the physical network so that the requirements of each of your applications are met consistently and independent of the configuration of the physical devices. This makes your applications run more reliably and securely while reducing the churn in your physical network config. Even if you grow your physical network infrastructure, you don't have to worry about breaking the apps that run on top. And your apps can immediately take advantage of new resources. Let's go hands-on to see it in action. We're going to start by creating a virtual network for a two-tier web application. We'll give this application its own network to keep it isolated from any other applications on the same infrastructure. In this network, we'll create two subnets, one for the front-end web servers and one for the back-end file servers. We start by creating a set of objects that represent the virtual network, and within these, we add a virtual subnet for each of our app tiers. We then apply the settings to create the network. Once the network is created, we can attach each of the VMs to it. In this case, we have a helper function to do this, and we call it once for each of the VMs we want to connect. Now let's see the results in one of our web server VMs. ipconfig shows the IP address that we've been assigned, and we can do a ping to see basic connectivity to another web server. We can open up a browser and connect to the default IIS web page on that server to show that, yeah, it's working. In this demo, we created two subnets, and since these two subnets are part of the same virtual network, virtual router got added automatically so VMs can communicate across subnet boundaries with no extra effort. This is great for one VM, but what happens as the load on your application grows? Load balancing becomes critical in order to scale out. And so Windows Server 2016 Data Center includes an all-software load balancer for use with SDN. You can use the software load balancer by creating virtual IPs or VIPs on top of your application tiers. These VIPs are the single entry point into the multiple VM instances of an application that make up the tier. And as the needs of the application grow, the number of VM instances can grow as well. The load balancer will continue to make sure the load is distributed evenly. To achieve this, in the next script, I'm selecting a front-end virtual IP for my services, creating a back-end address pool to contain the VMs that will respond to the request to the VIP, and finally, I'm connecting the two with some load balancing rules. In this case, I'm saying TCP on port 80 of the VIP will get distributed to the back-end pool members. Let's apply the load balancer configuration. The next step is to add the pool members to serve the requests. I do this once for each of my web server VMs. Applying it only takes a few seconds. Now let's see the result. I've placed a uniquely colored page on each of the web server VMs, so depending on which VM serves the page, I get a different color. Of course, if I go to the main page, the app that I've actually deployed, in this case a blog, you can see it's also working. The software load balancer also has the ability to insert internal VIPs within the virtual network for load balancing between the tiers. While it's not required for the file servers in this example, it can be used for other apps that require databases or application gateways. So you know your services don't live in a vacuum. They need to connect to Active Directory, databases, and other services. For that, SDN provides hybrid connectivity to the networks containing other existing services in the same or remote data center. The application owner defines their own gateway configuration that once again uses shared infrastructure to connect to the outside world with minimal involvement from the network admin. Types of gateway connections are as flexible as the needs of the application and include multi-tenant VLAN routing, site-to-site tunneling, GRE tunneling, or any combination of the three. To show you this in action, for this application, we're going to connect our virtual network to a VLAN with L3 forwarding. Here, we're starting one of the web server VMs. This time, we're trying to go out from the network. I started a ping to show it does not yet have any outbound connectivity. So let's run the script. Okay, the settings have been applied. While we're waiting for the configuration to go into effect, let's take a closer look at the script. The script first retrieves the objects that I'll be connecting. In this case, my virtual network is being connected to a VLAN in the physical network. This VLAN ID, 1002, has been pre-configured in my physical switch by my network administrator. It then creates a virtual gateway service on the virtual network and adds a connection referencing the VLAN subnet from the physical network. It gives the virtual gateway an IP address on the VLAN subnet. Switch back to the VM to watch as the connectivity gets established. Wait for the ping. There you go. Connected. And we can do a trace route to see each hop that it takes on the way out. There's the distributed router, then the virtual gateway, the physical router, and finally the destination. I now have the full ability to send traffic in and out of the virtual network via that VLAN. With this ability to create and connect to your network, the ability to protect it is critical. Cybercrime costs organizations millions of dollars each year. SDN can help here as well. By using the included distributed firewall, you can create micro-segmented boundaries around individual tiers of your application, permitting traffic to only those flows that are required and denying any flow that is not needed for the app to operate. When these rules are applied to the subnets, each VM automatically gets the required rules that are unique to its tier, even if that VM gets added at a later time. Let's add some protection to our web app now. We'll start by defining the rules for our web tier, and then apply those rules to the web tier subnet. That's all it takes. Let's go to the VM. We'll start by fleshing DNS to show that DNS lookups are still permitted. Now when we do the ping, we'll get the IP address back for the name, but the ping itself is blocked because we did not allow that in the rules. We'll open up Explorer to check to see that file server access is still permitted, because that's important for the application to run. We'll use the UNC path and connect to it by name. And there you can see we can browse the file share without any issue. We can also open up Internet Explorer to verify that the app itself still runs by connecting into port 80. So you can see each of the web pages still getting served. You aren't limited to Microsoft-only technology. If you've already tooled up by investing in a third party with a virtual appliance that runs on Hyper-V, you can add an instance of that virtual appliance to the virtual network and send traffic to it by taking control of the virtual network's routing table. This is called user-defined routing. Here we're adding a Linux appliance to our virtual network. You'll see the Linux appliance on the right. And you can see it has some background traffic to start because we haven't set up the rules yet. So let's run the script. You can see it's applying this routing table to the virtual network. And within a second, you can see all of the traffic destined for the .2 subnet is now being sent through the Linux virtual appliance for it to inspect and forward as it sees fit. Everything you've seen has been done in real time, done by the application owner without having to take time away from multiple other administrators. And it was done without losing any of the performance you expect from your high-performance hardware. When you're deploying your next app in your existing infrastructure, think about how much easier it could be with the agility of SDN, and go try it with Windows Server Data Center. It's all included in the box.